Okay, we did already talk about absolute value equations and how to solve them. I thought we had. Okay, so it was like, why is this here again? But we're going to tie it together with the functions. So let's look at this function right here. Okay, we could use transformations, right? Like we're expecting it to shift 1 to the left and 7 down. So 1 to the left and 7 down. It's not quite going to fit. And then we're expecting some kind of shift here. Let's just put in the number 1. Let's just get an ordered pair. What's f of 1? 4 times 1 plus 1 minus 7. So I'm just going to kind of do this. 4 times 1 plus 1 is 5, and the absolute value is 5, minus 7 is negative 2. Okay. So 1, negative 2, and, oh, I should have put in 0, huh? All right, well, we can put in 0, f of 0. I don't know why I did 1. I'm going to get 1 minus 7 is negative 6. Okay, my 7 maybe should be a little lower. Okay, this isn't working. Okay, so we have been talking about absolute value equations and how to solve those. We've done that in the past, and we're going to do that in a minute. But we're going to look at this function first because we know a little bit about transformations. Now, I've kind of been avoiding this, but they show it probably better in the book. But when you have a horizontal, let's see, this would be a horizontal compression. And it's hard to tell the difference with the absolute value if it's a stretch, a vertical stretch, or a horizontal compression because it's going to look the same. But we'll go with what they have written here. You can write that as 4 times x plus 1/4. Okay? And then that's going to make it easier for you to see where the shift is. Okay? So let's say you put in 0. Well, we can do that. F of 0. That's going to be 4 times 0 plus 1 minus 7, right? Okay, that's going to be a negative. You can do the math, but it's going to be negative 6. So there's a point right there on our graph. Now, what would I have to do to get that point to be 0? Like this shift here to be 0. I'd have to put in 1/4, a negative 1/4. Yeah. So that's a little bit harder to do. We haven't really done that. But you're going to get 0, and then that whole thing's going to be 0, and it's going to be negative 7, but it's going to be really hard to see on my graph paper here. It's going to be like right there. And then you could play around with it more. You could put in more values, but it did go down 7, right? Okay. And then it's going to go, let's do one more. Let's put in 1. We'll put in f of 1. So I get negative 2 when I do all that math. Okay. Now that should be, wait, it doesn't look very straight, does it? Okay, it's going like this. And if it's off a little bit, it's just I need a bigger piece of graph paper. The rest of it's going to go, the same shape off in the other direction. And then my graph is very weak, I'll give you that. But they don't ask us to actually graph this. They ask us to find the values of x such that f of x equals 0. Okay, so we're going to talk about that. I think we talked about when when the function equals 0, or the zeros of a function, those are the x-intercepts, right? Okay, so we're going to calculate the x-intercepts and then we'll compare it to our graph. So here comes the math. We want to know when f of x equals 0. When does this, the absolute value of a 4x plus 1 minus 7, when does that equal 0? Well, we can solve this. First of all, remember you have to isolate the absolute value. So we get 7 on the other side. Now we can do the two equations. Either 4x plus 1 equals 7. Oh, negative 7. I always put the negative case on the left so I don't forget about it. Or 4x plus 1 equals the positive case, the 7. Okay, subtract 1 and divide by 4. And I get negative 2. Oh man, my V is way off because it's supposed to be over there. All right, it should have been more like that. Okay, picture's way off. In the other case, if I subtract 1, 6, and divide by 4, 6/4, which is what, 3/2, 1 1/2. So it should have been more like right there. Okay, so my graph had trouble from the beginning because my graph paper was too small, but if I'd drawn it super accurate, it would have been, you know, like right on. But it's close. I mean, it's fairly close. So anyway, they didn't ask us to graph it. I just thought it would be helpful to see how the function and the transformations and the x-intercepts, how that all relates to finding the zeros or setting the function equal to 0 to find those x-intercepts. It's probably easier to do the actual equations and solve them than to graph it.